Algebra 1B, Monday the 28th of September. Students will be able to use function notation and evaluate functions. Section 4.2. So function notation. Notation, think about the word notation and look at the first part. It kind of sounds like you're saying notes. Okay? So notations, you're talking about notes, which just means writing. So when we talk about notation, we're talking about the way we write things. So we're talking about a special way that we write functions. We talked last class about what functions were. I compared them to the vending machines. That was what a lot of our homework was talking about functions on the back. Okay? Now, for function notation, we have an equation where it'd be y equals 4x plus 5. Okay? That could be a function. For function notation, we'll replace y with f of x. And that's how you read it, f of x, with y with f of x to show it is a function. So we can replace it with f of x because the f stands for function. Now it's called, it's read as f of x, and the value of in parentheses is used to replace or substitute x. So we say it's a function of x. Okay, so our vending machine would be a function of our money. Okay, so I put in $1.25, I push the button, I get my Snickers. Okay, I put in $1.50, push the buttons, I get my Butterfinger. Okay, I put in my 50 cents, push the buttons, I get my gum. Okay, so in this, if f of x equals 3x minus 4, that's the same thing as me saying in an equation that y equals 3x minus 4. Don't have to write that. You don't have to write that. But these are literally the same thing. This f of x instead of y just tells us it's a function. So we talked last class about plugging in x's and getting y's out, right? You guys remember that? Okay. Same idea. We're going to be plugging in x's, getting f of x out. And f of x is the same thing as y. Notation just means this is how we're going to be writing it for functions. So when I say, if f of x equals 3x minus 4, find f of 3. So we're just trying to figure out what this ends up equaling when x is 3. So I took the f of x, I replaced x with 3. So I'm going to replace everything that follows, every time I see x that follows, with 3. So instead of 3x minus 4, it's going to be 3 times 3 minus 4. So notice from the example, from the first part of the problem to number 1, I replaced x with 3, so I replace x with 3. Go and write that down. So how we got 3 for x, you guys remember last time in our notes how we said when x is 0, what's y? When x is this, what's y? You guys remember that? Yeah. Okay, same idea. We're saying when x is 3. This one will be when x is negative 1. This will be when x is 3a. So we're going to try all sorts of different things. But instead of saying x equals, when x equals this, we're going to say f of 3. It's just a different way of writing the same exact thing we were doing. So it's a different way of writing the notation of the exact same thing we were doing. Mason?
Isn't that the answer?
Nope. So we have to actually finish this off.
It's 5.
Okay? And we would say, well, what is 3 times 3? Because we do normal PEMDAS when we're not solving for a variable. So we're not solving for a variable, we do normal PEMDAS. So we do the multiplication first. So what is 3 times 3? 9. So I'm going to leave this left side as f of 3. Just like I left the left side before as y. Same idea, I'm going to leave this left side as f of 3. That's not going to change ever. Is that going to change? No, it's not going to change ever. Okay, let me ask that again. Aiden, is that going to change? No. Aiden, can you get your notes out, please? Thank you. So 9, and what's 9 stuff to do with?
Minus 4.
Minus 4. So what is 9 minus 4?
5.
So f of 3 is 5. That's just saying when x is 3, we get 5 out of our function. So when I plug in 3 into my vending machine, I get 5 out. That's as you drop things that sound like coins. Convenient. All right. Questions on number 1? Yes. Yes. How are you confused? So, notation just means how we're writing something. Okay, like notes. So we're just saying for function notation, to show it's a function, we're going to replace y. If this is y equals 3x minus 4, we're going to replace y with f of x. It means the same exact thing, and we use it the same exact way. It's just an f to tell us it's a function. And then we just, since we replace the x within the parentheses, we replace the other x's as well. And so just like we would leave y by itself the whole way, we leave f of 3 by itself the whole way. We don't do anything with this 3. Repeat, we don't do anything with this 3. On number 2, if f is negative 1, and we're using the same f of x equals 3x minus 4, can somebody tell me what I would do with the negative 1? I'm plugging it in for x, right? Yeah. Can somebody help me know what to write?
3x parentheses negative 1 minus 4.
Yep, 3 parentheses negative 1 minus 4. Okay, Aiden, what are your notes? So, 3 times negative 1 minus 4. Because negative 1 will replace x, negative 1 will replace x. So what is 3 times negative 1? Negative 3. So I have to write f of negative 1 again. I'm going to keep rewriting that. Negative 3 minus 4. So f of negative 1 equals what?
Negative 7.
And that's our answer. So when x is negative 1, our f of negative 1, or our y, they're the same thing, is equal to negative 7. When we put negative 1 in, we get negative 7 out. Questions on that? Okay, now on this one. What's replacing our x on this third one? 3a. 3a. So what are we going to plug in whenever we see x? 3a. We plug in both of them. We plug in 3 and a.
So a is x now?
So instead of x, we're using 3a. Okay. Instead of x, we use 3. Instead of x, we use negative 1. Instead of x, we'll use whatever shows up in the parenthesis. This time it happens to be 3a. So I'll write 3 times 3a minus 1, or minus 4, excuse me. So I'm going to replace whatever is in the parentheses for x. So what is 3 times 3a? 9a. So f of 3a is equal to 9a minus 4. Now, can we combine 9a minus 4? No, why not, Reagan? They're not the same variable, so they're not like terms. So f of 3a is just equal to 9a minus 4, and we leave our answer like that. We can't combine anything more. So notice when we do put another variable in there, we end up having a different variable in there at the end, don't we? Okay. So we'll plug in whatever shows up for that variable. Questions on that? Okay, so in addition, we can have different functions. So sometimes we'll have multiple functions at once, which is why this might be helpful for us. One of the reasons it might be helpful for us is you write it as f of x instead of y. So we can go on to the next letter. We can use what follows f. G. So we can use a g of x. We can use an h of x. We can use an I of x. We can use a j of x. You can keep going and going and going. Now, just because something is called g of x doesn't mean you call it a gunction instead of a function. It's still a function, right? I'm supposed to get a laugh. Thank you, okay? Instead of a function, f, it's a function g. It just has a different name, right, Lainey? Yep. Head up, please. Okay? So let g of x equal negative 2x plus 3. So just g of x is just a different function named g. And h of x, so a different function named h, equals x squared minus 4x plus 9. And we're asking to find these values. So our first one is h of 2. So which one of these do I think I'm going to plug 2 in? My g of x or my h of x?
H of x.
Why h of x? I agree, but why?
Because of the h.
Because it says h. So can somebody help me plug 2 into my h of x?
2 over 2.
Not 2 over 2, but x is being what? What's x? What's happening to x in our h of x? Now multiplying by 2, it has an exponent of 2. It's being squared. So instead of x being squared, 2 is going to be squared. Okay? Minus 4 times what? 2 plus 9. Now, we are just doing order of operations, aren't we? So everywhere we saw x, we just replaced x with 2. And we said whatever was happening with it, the same thing's going to happen. So because x was being squared, 2 will be squared. Right, Aiden? Okay, what number are we on? Okay, that's what I thought, buddy. Let's make sure we're following along here, okay? Dial in, okay? So, as I'm going to go through this with my order of operations, what comes first here from my order of operations?
Exponents.
The exponents. We don't have anything inside parentheses that needs to be done inside parentheses, so we have exponents. So I'm going to rewrite my h of 2 every time. What is 2 squared? 2 times 2? 4. What is... and I can actually do that next part at the same time. I can do the 4 times 2 at the same time because it's separated by subtraction. So I can do 4 minus 8 plus 9. Now, if those were not separated by subtraction, I couldn't do it at the same time. But because they are separated by either addition or subtraction, it's okay. Because that would have been my next step anyway, right? Is to multiply that 2 and the 4. Okay. So now h of 2 equals 4 minus 8 plus 9. What would we do there first? 4 minus 8 or 8 plus 9? 4 minus 8 first because it's left to right. Okay, what is 4 minus 8? Negative 4 plus 9. So h of 2 equals 5. Questions on that one? So after we plugged it in, we ended up just doing a normal order of operations problem, right? We did that like the second day of class. Okay? Let's look at number 5. G of negative 3. Where do I think I'm going to plug this negative 3 into?
The G.
The G. I'm going to use my G of x, the negative 2x plus 3. So it's going to be negative 2 times what? Negative 3. Very good, Reagan. Plus 3. I want you guys to go ahead and finish this one off. Finish number 5 off. All right, let's talk about this one. So, negative 2 times negative 3 is what?
Negative 6.
Not negative 6, but it's positive 6. So, negative times a negative is a positive. So, G of negative 3 equals 6 plus 3. So, what does G of negative 3 equal? 9. So, that means when x was negative 3, and we plugged it into our G of x, we got 9. So these G of x and H of x are kind of like 2 different vending machines, right? You guys see sometimes 2 different vending machines piled next to each other. One has stuff in it you might like, and one doesn't have stuff in it you like. Maybe one's drinks and one's food. Okay, you're hungry right now, you're not thirsty, so we're going to plug it into G of x. On number 6, maybe we're thirsty. We're going to plug it into H of x. We're going to plug it into the drink vending machine instead. Okay, so H of negative 2. So which one am I plugging that one into? H of x, the x squared minus 4x plus 9. Who can help me plug this one in? Dope. Go ahead.
Negative 2 squared
Okay.
minus 4 times negative 2
Okay.
plus 9.
Very good. So we'll make sure you have that down for number 6 here. Now we have to be very careful. This is why I use parentheses. This right here is one of the main reasons why I plug things in using parentheses. You actually technically don't have to, but it can be very helpful. Negative 2 being squared. This is saying negative 2 times itself. What is negative 2 times negative 2? Positive, not what?
No, positive 0.
Positive, nope, not quite.
Wait,
2 times 2 is?
positive 4, sorry.
So positive 4. Negative 2 times negative 2 is positive 4. A lot of us might have wanted to write negative 4, right? Okay, that's very common. We have to be very careful. We're squaring whatever's inside the parentheses. So we're doing whatever's inside the parentheses times itself. So in this case, a negative times a negative. Now what is negative 4 times negative 2, though?
8.
8. So we put plus 8. Very good.
Wait, negative 4.
So how do I get negative 4? So I can say subtraction is really just adding the opposite of whatever's there, right? So I could say that's adding a negative 4, and we can think of it that way. Otherwise, you'd have 2 negatives in a row on the next step, and it'll turn into addition anyway. Questions on this so far? Okay. So h of negative 2. What is 4 plus 8 plus 9? You guys could do this in the same step if you want. Okay. So 4 plus 8 is 12 plus 9. What's h of negative 2? 12 plus 9 is 21. Good, good. All right. Questions on number 6? Let's look at number 7. We're back in the g of x. G of 2 plus 5. Is that plus 5 inside or outside the parentheses? Outside. So what are we plugging in for x? Just 2. Whatever's inside the parentheses. So this will really equal our g of x. So negative 2 times 2 plus 3. Then we're going to say plus 5 at the end. So we do all of our g of 2 right here. The negative 2 times 2 plus 3. And then we add on the plus 5 at the end. We just tack it on at the end. Just like it's written there. Questions on how he got that?
No, sir.
Dope. You dang dope and Liddy. Okay? So now we go through order of operations. So now we have more to write each time though, unfortunately. G of 2 plus 5. What do we do first here? Tucker, what would you do first? And you get what? Negative 4 plus 3 plus 5. Very good, Tucker and Laney. G of 2 plus 5. Negative 4 plus 3 plus 5. What's negative 4 plus 3? Negative 1. So G of 2 plus 5 equals what? 4.
Do we have to rewrite it each time?
The G of 2 plus 5?
Yeah.
So if you want in the middle steps, you could leave it blank, but make sure you put the equal sign there at least so we don't forget it. Because my worry is if you don't write it each time, you're going to forget it. That's my worry. You technically can just put the equal sign each time and then write it again at the end. Okay, great question. Okay. Whoo! Number 8. 2 times all of g minus g of negative 1. So what's inside the parentheses for x? Negative 1. So we're going back to our g of x. And we're going to take... I'd wait for you to write what I'm going to write, okay? So write after I write it. We're going to take our negative 1 and plug it in for g of x. Thank you. We're going to take negative 2 and we're going to take negative 1 and plug it in for x. So negative 2 times negative 1 plus 3. But now we have to take this whole thing times 2. And that's what it's asking us to do. It's asking us to take 2 times whatever g of negative 1 is. So we're going to take 2 times whatever g of negative 1 is. So because we put these brackets there, that's going to tell us we're going to have to do everything inside of them first, right? Before we multiply it with 2. So we're going to do everything inside of there first, get g of negative 1, and then we're going to take 2 times that. Just like over here on number 7, we just did all of g of 2, and then tacked on plus 5. Same idea. We're just taking 2 times everything now. Questions on that? Give me a thumbs up if that made sense, thumbs down if it didn't. Nowhere in between. Give me a thumbs up if that makes sense. Thumbs down if it didn't. Nowhere in between. Everyone give me a vote. Everyone give me a vote. I'm seeing like 3 votes. Thumbs up if it made sense. Thumbs down if it didn't. Give me a vote. Okay, I'm seeing a few more votes. Thumbs up if it made sense. Thumbs down if it didn't. Okay, cool. So what we do here is this is saying to bracket. So whenever you have something outside of a bracket with something inside of a bracket, that means multiplication, right? Okay. So here we're doing 2 times g of negative 1. If I physically cover up the g and the negative 1, or the 2 there, we would just take g of negative 1. We plug negative 1 into g, right? Okay, so that's what we did if I cover up the 2. We take a negative 1, we plug it into g. Now I put the 2 bracket back on. We're saying we're going to take g of negative 1. We have to multiply by 2 when we're done. Let's try it out and see if this makes a little more sense here too. So 2 times g of negative 1 equals 2 times, what's negative 2 times negative 1? Because inside the parentheses, we're going to work inside out. So we have to work inside the brackets first, inside our grouping symbols. What's negative 2 times negative 1? Positive 2 plus 3. Hayden. So now, inside the parentheses, or I'll still write, the 2 times the quantity of g of negative 1.
That's too many steps, I feel like.
It's quite a bit of steps. It's meticulous. It's a lot of.
But do we have to do that on the all those steps?
Write this out or all these steps?
All the steps.
All the steps, yes. Okay. What is 2 plus 3?
5.
5. So g of negative 1 is 5. But now we need to do the multiplying by 2, because that's what it's asking us to do. Take g of negative 1 and multiply it by 2. So 2 times g of negative 1 equals 10.
Oh, Lord.
Oh, if you guys think that's a lot, you guys are going to have a miserable time here coming up.
Oh, great.
Oof. Okay. Questions on that one? Does that make a little more sense?
I regret me saying this was Egypt.
All right, give me another on this problem on number 7 here, or number 8 here. Thumbs up if it made sense, thumbs down if it didn't. Nowhere in between. Thumbs up if it makes sense, thumbs down if it didn't. Nowhere in between.
Kind of.
Okay? Kinda not. Okay. No, I said literally nowhere in between. Okay? Emily, what doesn't make sense about it to you?
I don't. It's a lot of brackets and stuff.
Yeah.
That's kind of what confuses me. Is brackets and stuff.
Do you understand why the brackets are there? Okay. So brackets are like another set of parentheses, right? Do you know that? Okay. So they're here right now because what would it symbolize? What's happening between 2 and when it's inside the bracket? What operation would that be? Multiplication. Okay. So we'd be multiplying it. So now we're not trying to take 2 times negative 1 because we're not trying to replace what's in the parenthesis, because that's just what's going to be plugging into x and my g of x, right? That's what we've done earlier. So it's like we took h of 2, for example, or g of negative 3. It's like we took another one of these, and I just said, okay, but now what would this be if I multiplied it by 2? And so then I would say, okay, well, let's multiply this by 2. So now that would effectively multiply by 2, right, Emily? So then I'd have to say, okay, I have to do the other side. So I'd multiply this whole side by 2. And that's really how we end up getting here. That's how those brackets get there, is because we're doing 2 times g of negative 1. So inside the brackets, we have g of negative 1, just like inside these brackets up here on number 3 now, or number 5 now, we have g of negative 3. Does that make any more sense or no? A little bit? Okay, Aiden, were you paying attention to that? Okay, did that make any more sense for you? Okay, are you just saying that? Okay. Mason.
Why do you get to pop all the steps down?
So if you can skip a couple steps here in your head, okay, do that.
That's what I was asking.
Oh, then yes.
Okay.
Okay.
I was gonna say.
I'm doing them here to make sure we don't miss them.
Okay.
Okay? Because some of us are going to get lost if we skip steps. Is that fair to say? Some of us can handle that a little bit better than others, and that's okay. But I want to make sure I'm covering it for those that can't handle that, okay? Let's look at G. G of a minus 1. So what is all in the parentheses here? A minus 1. So what are we going to plug in for G? Or for X, excuse me.
Negative 2. Wait, yeah.
So we're going to plug in for X here. A minus 1. So let's just start out by writing it. Negative 2 times a minus 1 plus 3. So we're just going to write that out. Okay, at first we don't question it. We just say, hey, I'm going to write whatever's in the parentheses, replace it with that, replace it for X. And then we'll work on solving them. Then we'll work on what to do after that. But at first, Aiden, we're going to just replace X with whatever's inside the parentheses, okay? So make sure we do that. Make sure we do that. Okay. So now with that being done, I said on the left-hand side of the equation, I could just put the equal sign there in my in-between steps. So I'll do that. I'll demonstrate that. What would I do here mathematically on the right-hand side? I could distribute. What's negative 2 times a?
Negative 2a.
And what's negative 2 times negative 1?
2.
Positive 2. And I still have my plus 3. Aiden. Oh, I thought you were raising your hand. Okay. Now can I do any more on my right-hand side now? Do we see more that I can do on my right-hand side after I distributed? I can do combine like terms, my 2 and my 3. So I get negative 2a plus 5. Is there any more I can do?
Nope.
This is my last step, so I better make sure I remember to write my g of a minus 1.
Oh, that's how you would do.
Yep, so if you were to skip the middle ones, you'd write it the first and the last.
Yeah, no, I'm saying like, I thought you had to times it by 2, like the whole thing, like the last one.
So great question. So the reason you don't have to times this one by 2 on number 9 is there's on 8 there's a 2 outside of everything with the brackets. Here, is there a 2 outside of everything with the brackets? No, it's only the negative 2 is only outside the a and the negative 1.
Okay.
Yeah, great question. Okay. Any other questions on this one? Okay. Evaluate the function f of x equals 3x plus 1. Evaluate just means plug things in and simplify. Okay, evaluate just means simplifying. Simplify the function f of x equals 3x plus 1 when the domain is negative 4, negative 2, 0, 2, 4. Domain is what values, x or y? X. So we know the x values are these 5 different x values. So what's it really asking us to do? Plug in each and every one of these one at a time and solve for f of x.
Oh my god.
Oh my goodness, y'all are a bunch of whiners and complainers. Okay, it's not that bad.
I actually did it.
Okay. So we're going to take f of x equals 3x plus 1. So at first, we're not going to have f of x, we're going to have f of negative 4. And what would f of negative 4 equal? 3 times negative 4 plus 1. So notice there, I just replaced x with negative 4 because that's what my first domain is. And so I replaced the other x with negative 4 as well. Tobin, what would you do first here?
Distribute 3.
Okay, so 3 times negative 4 is?
12.
Yep, negative 12. Good catch. All right, and then do I do my 3 times 1 or no?
No.
No.
No, why not?
Because it's that's the next step.
Okay, because 1's outside the parentheses, right? Okay, so I have negative 12 plus 1. So what is f of negative 4? Negative 11. So we're just saying, hey, when we plug in negative 4 for x, the y, or f of x we get out, is negative 11. Let's do the next one. F of what?
2.
Negative 2 equals 3 times negative 2 plus 1. What was 3 times negative 2? Negative 6 plus 1. So we get negative 5. I want you guys to try the other 3. When you have them or have questions, raise your hand. Okay, f of 0 is 1. You guys agree?
Yes.
Okay. F of 2. Mason, what's the answer?
7.
Okay, it is 7. Very good. F of 4. Tobin, why don't you give me the answer?
Equals 12.
Try again. There you go. 13. 12 plus 1. Yep. All right. Do you guys agree with those two? Yeah. Okay. And the nice thing with this is it's easy to see. Well, what did I plug in to get 13? I plugged in 4. What did I plug in to get negative 5? I plugged in negative 2. You can easily see quickly. Okay. Does that make sense?
Yes.
Okay. Questions on these? Okay, on to our last two. Find the value of x so that the function has the given value. So here we're told f of x is equal to 3x plus 1. That is our function. And additionally, after the semicolon, additionally, we're given the information that f of x equals 7. Now remember, what did I say f of x was basically the same as? Y. I said f of x is the same thing as y. So this would be like y equals 3x plus 1. And we're also told that y is equal to 7. What would you do if I told you that y was equal to 7 for y equals 3x plus 1?
X is 7.
What if I told you that y is 7 for y equals 3x plus 1?
Plug it in.
Plug in 7 for y.
Yeah.
And you write 7 equals, you write it like this, 7 equals 3x plus 1, right? And you solve for x. Here,
Wait.
y is the same thing as f of x, right? So we're going to plug in this 7 for f of x. This is the one time it changes. Because is the 7 inside the parentheses here?
No.
No, so it's different. So instead of f of x, we're going to put 7 because we're told right here, if you look at my hand, we're told right here that they're the exact same thing. That's subbing in a libero for libero. Okay, although you wouldn't really sub in the libero for libero usually unless you're making a lineup shift. But that's subbing in a quarterback for a quarterback. That's subbing in an outside hitter for outside hitter. That's subbing in a trombone player for a trombone player, okay? So 7 is equal to 3x plus 1. Because we're told all of f of x is 7. So don't get confused here because 7 is not in the parentheses. So it's different. We still have all of our f of x. We're told it's the same thing as 7. So we can replace all of f of x with 7. So how would we solve this equation when 7 is equal to 3x plus 1? Minus 1. Subtract 1. So we're back to SADMEP because we're solving for a variable. We're solving for x here, so we get back to SADMEP. So we subtract 1 from each side. What is 7 minus 1? 6 equals 3x, and 1 minus 1 is 0. So now what do we do?
Divide by 3.
Divide by 3. What is 6 divided by 3?
2.
2, and 3x divided by 3 is just x. So find the value of x so that the function has the given value. Well, when x is 2, f of x, or our y, is 7. So this is saying, let's figure out what we have to plug in to get 7 out. So this is saying, hey, we got 7 out of the function. So what did I plug in to get that? Oh, if I plug in 2, I get 7 out. So you could check it by plugging 2 back in to the function. Does that make more sense or no?
Yes.
Let's look on number 2 here. G of x is equal to x plus 5. Now we're also told that g of x is equal to negative 2. So is that negative 2 in the parentheses? No. So what am I going to do with that negative 2? I'm going to replace the g of x. So I'm going to have negative 2 equals x plus 5. Once again, we're trying to say, okay, we got out of this function, our g of x, our gunction, negative 2. We got negative 2 out. So we're saying, what did I do to get that? What did I plug it into? What can I plug in to get that? We have the end, but we don't have the beginning. So we plug in our end, and we work backwards. So that's why we're doing our StatMap, because we're working backwards to go from the end to the beginning. So, negative 2 equals x plus 5. Emily, what would you do? Subtract 5. What's negative 2 minus 5?
7.
What kind of 7?
Negative.
The negative kind. Same signs, add and keep the sign. Negative 7 equals x. So if I plug in negative 7 for x as in my gunction here, my g of x, I'm going to get negative 2 out. Questions on that? Okay. All right, guys, flip